crop circle, which was reported or created on the 1st of June, 2008. This circle sat around for a while before it was decoded by this gentleman here, Michael Reed. Yes, he was an astrophysicist. That's why this became a little more mainstream, a little more well-known circle than other ones. Because I'm sure if just any old Joe decoded this circle, it probably wouldn't have gotten as much attention. Who knows? Anyway, Michael Reed decoded this and found that this circle contained 10 digits of pi. And what's interesting is that it's also a circle that's divided into 10 parts. Over the years, some people have picked apart the geometries, and you can note here that it's a 10-fold geometry with several rings. There's 10 small rings in here, and then you've got this wide one here, and then the center circle. So you can see that there's lots of 10-fold, 10-digit geometry, 10-fold geometry going on many levels. Circle looks like a spiral from the center outward. We say it goes from the center outward because of the numbers pi, and I'll show you how the numbers pi work here. I mean, it's a pretty popular circle. I mean, a lot of people know how to solve this one already, but basically it's in divisions of 36 degrees. Every 36 degrees is considered a 1. And then if you look at each one of these rings, they travel around for a certain amount of arc. And that is, that's the decimal place, the digits. It becomes a digit of pi or whatever. You see there's 3 here. Then there was actually a decimal place on this crop circle. Right here, a little decimal place, right? And then we have a 1, and then a 4, 1, 5, 9, 2, 6, 5, 4. Gives us our number pi. And then of course we got these 3 circles, which kind of represent to infinity or just a continuation. If you look at this geometry, it shows you that this circle is based on 7. You have a radius of 7, then you can divide it up into each of its separate rings, draw out the geometry like so, divide this circle into 36 degrees. You could trace out pi. What's interesting is that you could do this with any number now. I mean, you could really divide up a circle by 10. You start with the center, and then you can draw out any number that has a decimal place that continues, like phi. Because you're using 10, we only have 0 to 9 that you can represent. You can use a wheel like this to show numbers. Pretty cool. I don't know how you'd show 0, but interesting that pi shows up here without a 0. It's cool. So nothing particularly amazing about this. People decoded it as pi, and that was that. And they were actually pretty amazed at this little drawing and how somebody came up with it, or whoever came up with it. It was kind of unique, so pretty cool. On June 21st, 2010, this crop circle was reported or created or whatever, which appeared to show a golden ratio, 1.61803399 in the decimals, in the number places here, right? It's a rather huge circle. There's people right here, you could see them. Massive, I think this was like 300 feet in diameter or something like that. And so the way you decode this one is that you start here with the empty spaces that they've flattened out, and you start here with a 1, sorry, right here. Then you skip a space, and this becomes a decimal. Then you skip a space, and then it's 6, skip a space, 1, and so on and so on. 8, 0, 3, 3, 9, 9, and it just repeats. What's always puzzled me about this particular crop circle was the outer track. You know, it's kind of just there for no reason, and same with these empty spaces here. I mean, why would they just blank out these empty spaces? Just didn't make sense. And then even trying to decode this number, if it is a number, it doesn't actually lead anywhere. So, but then I counted the divisions, and this actually divided it by 20. And if you count the number of rings we have here, there's actually 12 rings, including all the way out to the edge. So if you count this extra ring here, it's 12 rings. Okay, so we have one circle here that shows us pi in a spiraling manner, and then we have another circle here that shows us phi in a radial manner. It's like a radial burst from the center outward almost. And what's really interesting is that these two geometries actually fit on top of each other really well. And I'll show you what that looks like when you line them up. So here those two circles overlapped with each other, and I've kind of positioned them so that this 3.14 is on top of the 1.618, so the decimals sort of line up. And so I don't know if this decimal is supposed to be here or set one back, but I mean, people can mess around with these two circles and find out for themselves. But either way, it's really interesting to see that these circles actually line up really nicely with each other. And there might be some kind of significance because you have this radial design, and then on top of it or underneath it, you have this pancake-like coil. It's shaped according to the number pi, right? So this circle here reminds me of a coil, like a pancake coil that you would wind up in such a fashion. And this circle here reminds me of a rising sun magnetron anode block. So like a magnetron, you know, the shape of a magnetron, it's similar to this, but cavity magnetron. But this has a variable cavity pattern. And to have the pi-shaped coil on top of this, or powering it, or picking up the energy, or using it as a sensor, or whatever the case may be with the pi spiral, and this magnetron I'm just curious as to what kind of output it would produce. What kind of energy outputs would these produce if this was a cavity magnetron and this was a pancake coil together? You know, if you combine these two technologies together, what would actually happen? It's an interesting idea. So you guys down in the comment section, leave me a comment why you think it was really important for ancient people to relate pi